Hello, college algebra class. This video is about average rate of change, which is the next section that we're going to talk about in the book. And I just want to give you a brief idea of what it is before I ask you to do a couple problems here. So average rate of change is basically like a slope, but it's for a function that might not be a line. In the past, we've only talked about slope when we've dealt with straight lines, but now we're going to talk about it with more complex functions. Like this one right here. This is a parabola, and it has an average rate of change even though the slope is always changing. Like it's going down, say like x equals -5 or x equals -2, but then it is going up, say at like x equals 1 or x equals 3. So we're going to talk about how to find the average rate of change. So an average rate of change is from one place to another place. So just as an example, I'm going to do let's go ahead and say from x equals 1 to x equals 3. So that's kind of an approximation of where the function is at x equals 1 and where it is at x equals, well, it looks more like 2.5. I couldn't really see on my screen. I'm going to change that to 2 to make it a little bit, well, I'll change it to 3. I'll make it a little bit higher. So it'd be up there somewhere. Yeah, it looks a little better. Okay, so the average rate of change is the slope in between there. And the slope is not constant, it is bending a little bit. So to find the slope, we want to picture, like we did in intermediate algebra, a slope triangle. When you're doing these graphs, you don't have to, when you're doing these problems, excuse me, you don't have to make a graph every time, but it helps me to at least picture them. So we want to picture the rise and the run. So the run is so the run in between those two is 2 because we're going from 1 to 3. And the rise, I can't tell what it is on my graph, partially because I didn't make it tall enough there, and I didn't do a great job of that. But you can use the equation to find this out. It looks like it's 2 at 1, but I can plug that in to find out for sure. Alright, so it looks like it's supposed to be 3, which makes me think my graph is even worse than I thought it was. But so that means it's at 3. So at 1 it's 3. And at 3 I'm going to plug in again to figure out how high it is. Just do a little calculation here. Let's see, 3 squared plus 2 times 3. So talking about the change from 1 to 3, at x equals 1, the output, the y value is 3, and at x equals 3, the output, the y value was 15. So the rise of that, the change, is 15 minus 3, which is 12. And so the average rate of change, my final answer is 6. Because that's what it simplifies down to be. And this idea of average rate of change is kind of like the slope, but it's for something that does not have the same slope all the time. If I found the average rate of change in a different place in this parabola, I wouldn't get 6, I'd get something different. But from 1 to 3, it's 6. I don't want to make this video any longer than it has to be in parts or watch the whole thing again. Good luck.